and we had all these things. We overloaded like 4 operators here, the addition operator. The compound addition is the plus equals. Then the scalar multiplication with a complex number. By scalar here we mean like integer like 2. Just 2 multiplied with a complex number. And can someone tell me like why do we need these 2 versions? In the sense, why is the same operator for multiplying scalar is written like 2 times? Yeah, so the answer is because you can even have it like the complex number multiplied by scalar, which is the second version here, or you can have the other way, the scalar multiplied with the complex number. And so in operator overloading, so the important thing to note here is like always the order of the arguments matters a lot, in the sense if you say complex number 1 plus complex number 2, what it means is complex number 1 plus, dot operator plus of complex number 2. So the order in operator overloading matters a lot. And can someone tell me like why do we need this friend here? Why do we need a keyword called friend here?
You can access that method in other classes.
So you can access the private data fields of this class. So actually, if you think about it, these 2 methods, the last 2 methods here, the operator star using the scalar and the complex and the scalar are not member functions. This is a very important point, are not member functions because of the keyword friend. What do we mean by that? You cannot call that particular function on an object of type complex. You cannot call these 2 functions on objects of type complex, but instead you can call them like directly. You can just call them operator star. So for example, so this is like a simple main, again very similar to whatever we had last time, but I removed most of the unnecessary things. So here we are creating 2 complex numbers and C3 is equal to C1 plus C2. So now if you want to like multiply, and the output is here, okay? Yeah, you can see the output. This is C1, this is C2, and the addition of 2 complex numbers is here. So now if you want to just like multiply 2 complex numbers in C3, you can say C3 equals, or like if you want to multiply a scalar and a complex number, you can do it like this because we have defined this operator, and then we can say C3 dot print. Now if you see here, C3 now has changed this value to be 2 times that of C1. We have just multiplied this by 2. And what is happening here is nothing but we are just calling this is just equivalent to saying C3 is equal to call that friend function, which is like a free function. By free function we mean it does not belong to the class. It is not a member function of the class. We are calling the free function called operator star with 2 and C1 as the arguments. So when we call this, first we are giving the scalar and then the complex number. So this method, scalar and complex number, the first type will be invoked. And if you see here, we are not calling this on any object. That's like the important thing here. We are not calling this operator star on any object. By that here we mean, here the same line, you can just convert it to, this addition is a member function, and so here instead of this you can just have C1 dot operator plus of C2. So here we are calling that operator plus on the object, on the complex object called C1, but here we are not doing so. Here we are just calling it as if it is like a free function, and since it is a friend of this particular class, what it is capable of doing is like inside this function, the operator star, it can directly access the private data members of the complex class, which is the real and the imaginary. We need not go through the member functions, the getters of the class. And in our case, we have not even defined any getters for real and imaginary. And this actually breaks encapsulation. If you think about it, using friends actually breaks encapsulation, which is a bad thing, okay? But why this is needed is like, if you think about it, when we are actually writing our own classes, we will not use friends that often. But for containers, like in the standard library, when there is like a vector, and if you remember, on top of vectors we have iterators, right? And so iterators are a different type of objects. Vectors are different types of objects. But iterators should have access to the contents that are stored in the vectors, and then only we will be able to maybe set or get the values using the iterators. And so if you open the vector class or map class, you can see that the iterators would be friends of those classes. So it will be very useful in those scenarios, but usually whenever we are in class, we will have like getters and setters, and so we will be using them. Even in this case, if we had getters and setters, okay, we would have not made these operator star to be friend functions, but instead they would be just free functions. By free functions, I mean it will be just inside that file, but it can use the getters and setters of that particular complex class to access the real and the imaginary. Okay. Any questions about friends? The friend keyword or the friend function? So in today's class, the topics that we are going to discuss are like little more about operator overloading and const. We are going to discuss about const correctness and then the templates. Okay. So these are. Okay, so these are the 5 topics that we are going to discuss today. So we will start with overloading the stream extraction operator or the left shift operator, which we usually use to print something, right? So in our complex number, till now we were printing using like C1.print, C2.print and C3.print. Okay, whenever we wanted to print, we are printing it like this. But what if we can print, assume we want to print C3 here, and what if we can print it directly like this, Cout C3. Okay, would this be useful? Directly printing a complex number as an integer or as a string. Okay, but this would not happen on its own. By that we mean, if you keep here, it says binary operator, the double arrow operator, or can't be applied to the expression of type O stream. This is O output stream, O stream, and the complex. You cannot apply this operator on these two different things. And so, if we want to make this possible, okay, then we have to go inside of a complex class and we have to overload this stream extraction operator. Okay, or this is, I think, the stream insertion operator. Yeah, we are inserting this content to that particular stream to print it to the output. Okay, and so here we go here, and then in a very similar way. And now, first, even before starting to add anything, you should think about this. Okay. Just think about the highlighted thing. We are saying std cout, this operator, and then C3. So what this means internally, if we want to write an operator overloading for this, should we write, the first decision that we should make is like, should we write a member function or a free function? Can someone tell? Should we write a member function or a free function in this case? Yeah. So the answer is like, we can make it a member function so that we can access all the data inside. Okay, any other answers? Yeah, can do that also. So here in this particular case, okay, we have this. We should immediately think about how will this be converted with respect to operator overloading. With respect to operator overloading, if you make it a member function, okay, it will try to call on the left object, okay, which is nothing but std cout. It will be similar to std cout dot operator, this operator sign, and C3, which wouldn't make any sense. We are trying to call something on the std cout object. That's the main thing that we have to understand here. So here, this line, if we write it as a member function, it will get converted to std cout dot operator of C3. So we are saying call a member function on this std cout with the name operator star, which wouldn't make any sense. We are trying to write a member function in the output stream, which doesn't make any sense. Does this make, do you guys understand this? And so we should not make it a public, the member function, but instead we should again make it in a similar way. We should make it a free function, which is a friend of that particular class. So here again you will say friend. First, we need not worry about friend. Okay, first let's just make it as a free function. So the operator's name is operator this name, and then what is the input that it's going to take? Think about it. There are two inputs. One is the output stream, and the next one is our class object. So our output stream is std ostream, and you say output stream, okay? And then you say I'm going to pass in the complex number, which is, let's say, C. And what is this going to return? This particular operator will return a output stream, and the reason being, if it returns an output stream, you can think of this being the output stream, and to that output stream you can concatenate many other things. Whatever you want to print after that, you can just send it to the output stream. So this whole expression is going to return an output stream, and so you go here and just say this is going to return output stream, okay? And now let's try defining this particular member function. Sorry, not member function, a free function. Yeah, here we have defined this thing, and inside what we are going to do is, so this output stream OS, we can just treat it as std out. Now we are passing in std c out, okay, std c out as this output stream. So whatever you do for printing with std c out, you will do it with this output stream object OS. Just say OS, and you can just say I'm going to print the c dot real, and then I'm going to print a plus, and then I'm going to print c dot imaginary, and then I'm going to print space I. Okay. Now will this work? If we compile it, will this work? No. Why? One thing is we forgot the return value. Good. Return OS. Now will this work? No, because c.real, okay, we are trying to access the private members of the complex number from a free function here. So here you should immediately make this function a friend. So now you will be able to allow to access it, but even if we do that, let's see, let's just try compiling this and see what's happening. It says this operator is a binary operator, but it has like some 3 values. And even before that, the first error, it says like call to implicitly deleted copy constructor of OStream. Okay, so this error message would not make sense right now. But what is happening here is like here we are trying to pass this output stream, okay, and by value. By value, whenever you pass something, you will make a copy of that particular thing and send it to that function, right? So here, when you are trying to make a copy of the output stream class would not allow you to do so, because it is linked to the console output. So if you make a copy of that output stream from multiple places, you can just directly print to the console output. So the output stream wouldn't allow us to make a copy of that, and so the only way that you can pass this is using reference. So I am passing this output stream using a reference, and even the return type here should be a reference, again for the same reason. If you don't have like return by reference, here it will make a copy of this OS object and then it will give it to the calling method. But again, output stream restricts us to make any copies, and so we are passing it by reference. By passing by reference, there will be only one output stream in main, and we will be using the same output stream from inside this method also. So now when we try to run this, we have to like make the changes here too. This is a friend. We have this and we have a complex number. Here it is printing this. So it still thinks that, okay, it still thinks that we are, oh okay, the problem is it still thinks that we are giving this operator 3 arguments. Even though we are giving it only std out and the complex number, it is thinking that it is getting 3 arguments. The reason being, we still have this complex colon here. We still have it as a member function. If you have this syntax here, it thinks that it is a member function, okay? It is a member function, and since it is a member function, always this object will also, this pointer will also be pointed, will also be passed in as the first argument. So you need not worry about those details now, but the thing is, here, if this is a friend function, you should not have it have that syntax here. If you see here, this has a syntax because this is a member function. But here, we should not have that syntax, and once you remove that syntax, let's see what's happening. So now if you see here, we just printed our complex number C3 using std out C3. We have overloaded the stream insertion operator. Yeah?
And so the reason that you don't have it as a member of the class is because it would be passing C out as implicit bracket.
So because we are not having this as a member of this class, because if you have it as a member, it means that you have the left hand side object, okay? You have the left hand side object, you have the right hand side object. It means left hand side object dot operator whatever on the right hand side. But you are not the owner of this object, right? I mean, this is not even an object of your class, so you cannot do that here. But you can do that with the addition here because you are the owner of both. You have written like C1 and C2, so you know how exactly that works, and so you can just call it like this. And here, since now this returns an output stream, this particular expression returns an output stream, you can even like concatenate std NL to the end here, okay? And if you do it, it will print a line at the end. So what happens here is like this whole thing just gets converted to, I can show you the other way also. So this whole thing just gets converted to the free thing operator of std cout, C3, and here we are sending std end line. This is what is happening internally. You can just try running this to see if it also prints the same things. You see this? This also prints 4 plus 10i, which is C3 now. This is exactly what is happening internally. We are saying we have already defined this operator, stream insertion operator. Pass in Cout as one of the arguments, which is the output stream object. Pass in a complex number C3 as another argument, a second argument, and then now this whole thing returns output stream. To that particular output stream, you can insert whatever other things that you want. So in this case, we are inserting an end line. Does this make sense? This is what is happening internally, but we won't write code like this. The main reason we did this, the whole thing was to have code like this. Okay. Okay, now after this, what we are going to do now is, so we have this addition operator, okay? We have got, okay, now addition is possible here in our complex numbers, but something like this makes sense. If someone comes and uses your class, your complex class, and if they write a code like this, what this would mean, what a line like C1 plus C2 equals C3 mean? Can someone tell? Pardon?
You're adding 2 complex numbers.
Yeah, we're adding 2 complex numbers together, but that is done on the left hand side of the assignment operator. Does that make sense? Yeah.
Is it like in C where if you have a statement like that, that just evaluates to the left hand side of the statement?
Yeah, so it is similar to that. So the point here is like, okay, let's assume C1 and C2 are getting added, okay? There will be some temporary complex number there, but we are assigning C3 to be to that complex number. This is what is happening, but after that there is nothing that is happening, right? So this particular statement, you cannot do it with, let's say, this is similar to saying 2 plus 3 equals 10 or something like this. If 2 and 3 and 10 are in integers, we are doing something like this with complex numbers. But if you do it with integers, see here, immediately it says, the compiler says expression is not assignable, okay? It says you cannot do this with integers. It does not make any sense because when you're adding two integers, it should be on the right hand side of the assignment. In technical terms, it's called R value, okay? It's just called R value. This particular expression should be an R value, the right hand side value. It should not be an L value, the left hand side value. The same thing, but we are allowing the user to do with our complex numbers. The reason being, okay, if you go here, the reason being the complex numbers addition operator just returns a complex number, okay? It does not worry about anything, it just returns a complex number, and when you add two complex numbers, it just returns a complex number. But that complex number is being assigned to by a third complex number, C3. But how can we prevent this? Because if a user can write a statement like this, which is semantically wrong, okay, which is semantically, by meaning it is wrong, but if your class is allowing that, then you have not designed your class very well. This line should be a syntax error. When the user tries to do something like this, it should be a syntax error. To do that, we can make the output that is coming, which is C1 plus C2, to be a constant, okay? Whatever the addition operator returns, we can make that particular output to be a constant complex number, and so you just go and add const to the return type. You're saying this addition operator will return a const complex number. The same thing you should do it even here. This is going to return a const complex number, and so after doing this, when you go here, now immediately you see the red line here, it says expression is not assignable. Now users will not be able to write some expression like this. We have made the return type of the operator plus function or the overload of the addition operator for complex numbers to be a constant here. This is the first use where we use like the keyword const. And if you think about it, now again with the same operator plus function, okay, if someone, assume we wrote this code like currently, and someone in the next semester they are coming and using the same code, and if they are modifying it for the purposes, and if some student by mistake, if he or she goes inside this complex number class and does all these things correctly, but just for fun or like some reason they just say the right hand side complex number dot real, I am just making this complex number to be 0, the real part, and also I am making the imaginary part to also to be 0. This will not happen, but I am saying like, with the current code, if someone gets access to your implementation file, they can easily do this. And when, because this is like a very small function, you can identify these errors right here, but if it's a very big file, doing something like this is, like, we can easily expect something like this to happen. And so, now what will happen here? Okay, now we can't find this. Now we are saying C1 is this, C2 is 7, 8, and we are adding C1 plus C2, and we are printing C1, C2, C3, okay? And when we do this, so so here it would not, okay, in this particular case there is no problem here because the right hand side complex number has been passed by value. But usually we would not pass anything, okay, any like objects of any user defined types by value, because it's unnecessary cost to copy that particular object and send it to that function. Instead, we will just send this particular right hand side by reference. Okay, we will send it by reference. I am changing it to be by reference. And once you do this, now the complex number C2 is passed into this particular function by reference. And instead of being 7 and 8, we are trying to just modify that from inside this operator plus to be 0 and 0. And so once we print this, now if you see here, it has done the addition correctly with whatever complex number C1 and C2 we had. But when it is printing, now the complex number C2 has completely changed its real and imaginary part to 0 and 0. This is a problem, okay? And we are giving too much power, okay? We are giving too much power to the operator plus function in this case to even modify, because when you pass something by a reference, we are actually telling that particular function can actually modify that particular object that we are passing by reference. In our case, like in assignment 2, when we passed the vectors, all the vectors that were going through the pipeline kind of like clean data and everything was actually going by reference, which means those functions had the power to modify that particular thing. But in this operator plus, which is just an addition operator, this function should not have the power to actually modify its arguments. I mean, it should not modify the two complex numbers that are being added, because its job is just to like add these two numbers and just return that added value to the main. And so to avoid this, you just add const keyword in the argument. Here now right hand side RHS is a const reference. Okay, or they will say like it's a reference to a const complex. It's actually a const reference. So here what it means, like this RHS, using this reference called RHS, now you will not be able to modify the real and imaginary part of the complex number. You will not be able to modify the original complex number that is in the main function. Immediately if you see here, there is a syntax error. Const complex is read-only reference. It is a read-only reference, so you cannot actually modify it. If we try to run this now, it will immediately say, first I think we should like make this also to be a const. This is a second use of the const keyword, which is like in the arguments. And if you have it in the arguments, the read-only variable is not assignable. It clearly says you cannot do this inside this function, and so now this code is like not possible. Okay, you have to comment this out, and or you will understand that okay, now this function is actually a read-only function, so you cannot modify this. But the same function, even though has a const reference to the right-hand side argument of the two complex numbers C1 and C2. C1 is the this parameter, right? C1, whatever we are calling, is the this parameter. So now, even though this has a const reference, we are still allowed to modify this dot real. Say we make it to -1, and then this dot imaginary. Now still this function has the power to modify this object, in this case C1 plus C2. C1 is real and imaginary directly. And if you see here now, the first thing has changed. Even though we are adding the two complex numbers correctly, and then we are modifying C1 and C2, and when we are printing C1, C2, C3, now C1's real and imaginary has changed to -1 and -1. Still, this seems like this particular function is too powerful to even change the private data fields of the receiver object or the object on which this function is called on. To avoid that, this is the place where we used const. So you go to the declaration first, and at the end of this function you say const. So now this const at the end just means that this function, which is operator plus, receives a complex number using like a const reference, okay, returns a complex number which is a const complex number, and this function itself is const. By that we mean this function from this time on has no power to actually modify the receiver object or whichever object this is being called on. So C1 dot operator plus of C2. So C1 is the receiver object. So now from this point on, this function has no powers to modify the receiver object or this object. So all the getter methods that we have in classes are actually const functions. If you think about it, they should just return the value. Of the methods for printing are actually const functions. So you should also add the const keyword at the end here. Okay. Now it's saying like this is a const. Now immediately see here. Now this says real field real is assigned inside a const function. So you cannot do that. And if you try like running this again, it will say same read-only variable is not assignable. So hereafter you can't do this. Sorry about that. And so you can't like just now. Okay, okay, I've changed this. No, we should not do this. This example may seem like very trivial or like very childish because we will not be doing some things like this, but this was a very good place to explain the three different uses of the const keyword. So the first thing that we saw is in the return type. The second place we saw is in the past. The first thing we saw is here the return type, and the second thing we saw is in the argument that we are passing, which is a const reference hereafter, so that we will not be able to modify the actual object in the main. The third place, this may be the most, what to say, new thing for you guys, because this clearly says that this particular function is a const function, so it cannot change the state of the receiver object. By the state of the receiver object, we mean it cannot change any of its private data members. Okay? And so hereafter, from this point on in our course, we will be using, so this is not like optional. One more thing, like even though till now we were not making use of this const keyword, in real world programs, this const, using this const like in these three places in this particular function is not optional, but it is required. By required here we mean, if someone is working on the same project and if you have written this code and if this code does not, if this should not modify the state of the object, then this const should be there. If this argument is like a read-only argument, then again this const keyword should be there. So it is not an optional thing, but it's a required thing. Yeah.
So when you say that doesn't, the last one, so that's not modifying the implicit term.
Yeah, that's not modifying
I
the.
was really confused with this.
So this const keyword just means that it is not modifying the receiver object or the object on which this function is being called on. Okay, and having all your functions like using this const in all your functions in the correct way is called a const correctness. Okay, so by that here we mean, so if you go to this plus equals operator, okay, this a const, first let's say like is this a const method? Can we add const here? Can someone say, is this correct? No, why? Adding const here is like wrong, terribly wrong, because here you are actually, you want to modify the state of this, the object, the receiver object. You're saying star this is equal to star this plus right hand side. So having const here is like wrong, like completely wrong. So you should not have const here. Can we pass the, what to say? So here it's going to be like reference, and can we pass this by reference? Is this okay? Const reference. I think this is okay because like we are not doing anything with that. But you should also think about this. So now, since we had the const complex as a return type for the operator plus, can we add a const here? Okay. Now this will not tell any issues. Okay, const here. If you add const here, and one more thing that we can make, one more thing that we can make here is like we can say like the plus equals actually returns by reference. We need not make a copy while returning. We return by reference because we are returning this object which is already there, okay, which is already there in the main, which is C1 in this case. So here you can return by reference. But in this particular case, can someone tell me if we can return by reference? Const complex, can we return by reference here? We should not return by reference here because if we return by reference, we are returning a reference to a local variable called sum, which will be destroyed immediately after this function gets over. And that reference will be pointing to some memory which is already gone, which is not already in your control. So you should not return a reference for the operator plus, but you can return a reference for operator plus equals, because here you are actually just returning that this is not a local variable. This is a variable that is there in the main, which is C1 in this case. If you say C1 plus equals C2, this star this is just C1. So here you can return by reference, but not in the other case. But adding this const here is wrong for this particular thing, because you should think of all the different cases that people will use the plus equals. So C1 plus equals C2, and you can also have something like plus equals C3. This is a valid statement with respect to plus equals. You're just saying add C1 and C2 and store it in C1, and then with that value add C3 to it and store it in C1 again. Okay, this is a valid statement with plus equals. But now this will not be possible just because we made this, the return type of this, a const reference. If you made it a const reference, now it says like now hereafter I cannot modify this particular the return of C1 plus C2, and so in this particular thing here const is not, should not be there, for plus equals. I'm just explaining with these two methods, but constants will apply to all the what to say, member functions in your class. Now once you remove this, now this particular statement is possible. C1 is equal to C1 plus equals C2, and just comment out these things. So we have C1, C2, C3, and now this particular line should work. Just printing like C1 here. Okay. So now C1 is just the addition of these three complex numbers, because we are adding C1 and C2. To that value we are adding C3. Now C1 becomes 18 plus 26. Okay. And yeah, so now this is like the const correctness. So if you think about this print method, this print method should be a const method, because it should not modify any of the private data fields of the class, and so adding this is necessary. Okay. Even without this, your code will work, but yeah, adding const is like when you read like real world code, you will, the one keyword that you will find the most is like const. Okay, and having this is very useful. Okay, and the next thing that we are going to discuss is storing data in 2 dimensions, and let's see how can we do that. So in this particular case, we have, like, if you want to store something like a 2-dimensional array, how can we do this in C++? So you can create a vector of integers, and you can name that particular thing as a grid. Okay, and so now this is like a vector of integers. You can think of it like this. Now let's see how can we initialize this particular grid. So if you say grid.resize of 2, now the outer vector, okay, will just become like this. You have grid of 0 and grid of 2. There are 2 elements in the outer vector. And now when you say grid of 0.resize of 3, here I am trying to create like a grid or a matrix of 2 rows with 2 rows and 3 columns. Now I go into the first vector. Grid of 0 itself is a vector right now. So if I say grid of 0.resize of 3, now it will give me this. And now if I say grid of 1.resize of 3, now it will give me this, and it will initialize all the values to 0, because it is the integer vector, and this is how you create like 2-dimensional structures in C++. This is one way of doing that. Yeah. And if you want to access any elements here, you can just say grid of 0, 0 is equal to 3. And in this case, the first grid of 0 will just get converted to whatever we have here, and the next, in that vector which is grid of 0, we are accessing the 0th element, which is just this box, and we are saying just change that value to 3. This is all is happening. This is very similar to how you use like 2D arrays here. And let's see, like, why are we talking about this right now? Let's right now create a class. Okay, let's create a class called matrix. Okay, and we are going to create like a matrix in map. This is going to be a matrix class, and in the matrix there will be like rows and columns, and we can have a std vector of ins, vector of ins, and we call this, let's say, data. Okay. And we have the public functions. First thing that we usually write is the constructor. I'm writing the constructor here, and then one more parameterized constructor which takes in the rows and the columns. Okay, number rows and then on columns. And let's first just define these 2 things. So in this constructor, if someone just creates an object of type matrix, it is just going to have 0 rows and 0 columns. There is no matrix at all. You can just think of this in the initial state. and you need not worry anything about the data part because it is a vector of vectors. It will already be initialized with like a size of 0. And so here in this particular case, here you are saying like rows is equal to the rows of the matrix, the columns is equal to the columns matrix, and we should, in this particular construction, we should also initialize the 2D vector of vectors of ins. So here, first you just determine how many size you want, right? So the data dot resize, that's a method called resize. Now we are saying this is the number of rows in the grid or in the matrix that I am having. So this is just like rows. And then for each row, okay, for each row, what I am doing is I am just going and saying data of that particular row dot resize with the column size, which is the columns. This particular piece of code, whatever we have written in the constructor, is exactly what just happened. Exactly what just happened here.
Jump back to slides for just a second. When you first called resize.
Yeah, this is what, whatever we just did there is what exactly happened here. When you say grid.resize of the rows, you get like 2 rows, and then you go inside each and every row, okay, grid of 0.resize, you say like I want 3 columns in this particular row, and then again you say in the first row, again I need 3 columns. This is exactly what is happening inside this constructor, okay. Now we have this, and let's define a method for printing the matrix. You say void print, and this is a const void generating. So I'm saying like this is going to print this matrix, and the way we can print is using iterators. So I'm saying go through the data, the 2-dimensional vector of vectors from the beginning to the end, and I'm having a row iterator, and using that row iterator, just give me the entire row, the first row or something like that. When you say give me the first row, it is again a vector of ins, okay? And this is like, let's say this is the row data. We get the rows entire data here, and you get it by using star like RID. Just dereference this, and you get this. And then now you have to iterate through the entire data in the row to actually go and print each and every value in the column. So now this is going to be in the row data vector. I'm saying I'm having a column iterator, and then I'm just going to say HTTP print the column CIT with the space in between, and after every column, after every single row is being printed, just add a new line at the end. Okay, this is how we are just printing that matrix. And let's try creating. Now we will go to our main.cpp and let's try creating a matrix here. Okay, matrix with 2 rows and 3 columns. We have to find this matrix here. Hash define matrix.hpp, and then if I name, should do a name, let's say yeah, and the dot print. Okay. So do you see this? Our matrix has been printed here with 2 rows and 3 columns, and all the default values in our matrix is 0. Okay. Now, if you want to do something like, if you want to actually overload the let's first go to the use case. So in this matrix now, would it be useful to just say something like matrix of 0, 0 is equal to, let's say, some 3 or something like this, as we saw in the slides. If you want to have something like this matrix of 0, 0 is equal to 3, then what is needed here is this M is just your object, okay? And in your object, it does not know what it means to apply the array subscripting operator. You have to explicitly define what it means to apply an array subscripting operator to an object of type matrix. And again, we have operator overloading to our rescue here. So you go to matrix again, you just define a operator operator with the array subscripting and say this is going to take in an integer, which is the index of whatever thing that I need, and then it is going to return. Think about this. We have two-dimensional like array vector of vectors. So when you just index on the initial thing, you will get an entire vector. Is that correct? When you say like grid of 0, data of 0, that itself gives you the entire first row, which is again a vector of int. So this particular thing, overloading this operator, is going to return you a vector of ints. And this is going to be returned by reference because you should be able to like write into the vector of ints, which is nothing but you will be directly writing it into the data here, into this data here. And so here this is what exactly we are doing, and if you define this particular thing, and this index should be a const index because inside this method you should not change that index. Now I'm going to define this particular method, and here, yeah, we have this, and all you have to do is, this is a member function inside the matrix class. All you have to do is just say return data of that particular index. That's it. The data is a 2D vector of vectors. If you just say data of 0, it gives you the first row, entire first row, which is a vector of ints. And now this particular function returns a vector of ints. And in that particular vector, in main.cpp, now this particular thing, okay, the first m of 0 returns a vector of ints, and we are accessing the array subscripting operator one more time. We are using the array subscripting operator one more time to access a 0th element in the vector. Do we need to do anything for overloading the double array subscripting operator in our matrix class? Do we need to do that or not? No, we need not do that because this, we have done this part. We have told like what should happen when this is done. This already returns a vector. That vector comes here, and in that vector you are just accessing, you can think the vector is v. In that v you are accessing the 0th element, and the vector class already has overloaded the array subscripting operator for you. That is the reason we were able to use like till now v of 0 is equal to something, v of 1 is equal to something. Does this make sense? So here you just did operator overloading for one of the square brackets, which returns a vector of integers here, and on that vector of integers you are accessing the 0th element, and you are saying now this is equal to 3. And if you print this matrix after this, the first element's value should have changed. Do you see this? Well, the same matrix has 3 0 0 0 0 3. Now we have overloaded the array subscripting operator on the our matrix class. Okay. Is this clear? Yeah.
When you know to use the array subscripting operator versus like the dot at, because when I was using this prior to like looking early, I kept getting segmentation.
So the dot at is just like another way of using the same thing in a vector. It's very similar to the vector has provided you two different options to like ways to access the elements. Dot at, it does some bounds checking. If you say dot at, it checks if the index that you are passing in is within the length of the vector. It's within the range of the vector. But this array subscripting operator is provided to be like very fast, okay? And so it does not do that bounds checking for you. If you access, like in this case, if you access like that element to be like, let's say 20 or something like that, it automatically goes to some memory region then.
So do you recommend using one over the other?
So if you are pretty sure that you will be like doing it in a sane way, then you can directly use it because it's much faster. But if you think like maybe I'm not very sure what this index is, then you can use the dot at. The last thing that I just want to show you, it may take like just 2 or 3 more minutes. Please bear with me because this is like very useful. Whatever we're doing right now is directly useful for assignment 4. Okay. And the last thing that we're going to do here is, can we make this matrix, as of now this matrix only stores integers. Can we make this matrix to store anything that we want? Like let's say it should store doubles, or it should even store a matrix of complex numbers. Can we do that? Yes, we can do that. It's like very simple in C++. The way you do that is just say template. The same, hereafter this class is going to be a template class, and the type name whatever type that is, for example, if you're storing an int, this t will be int. If you're storing it as a double, this t will be double. You can just say it like this. And after that, here, wherever you have like vector of ints, here you will say vector of t. This is very similar to generic programming in Java. Okay? And wherever you have it, here also this should be vector of t. This should return a vector of t. Okay? And then you go to the matrix.cpp, and here everywhere in all the methods you should add this template thing. Okay? You should add this template, and you should say now hereafter this matrix is not just a matrix, this is a matrix of t, of type t. And in a similar way you will do this for everything. And even in this print, so in this print, just see like now this will become the temporary vector that we are creating, the row data will become a vector of t, not vector of ints anymore. And this matrix will again become matrix of t. And the last thing that we have here is this array subscripting operator. And again, this will be a vector of t. Where just t is just the type of this particular matrix hereafter. We are not bound to only have integers anymore. But in templates, if you have it like in HPP and the CPP file, it would not work. So after you have this particular thing, you can go to your main.cpp, and what you can do here is hereafter this particular usage of matrix, just m of 2, 3 will not work. It says matrix is not a class, namespace or scope enumeration. So what you should do here is you should say matrix of some type. I am creating a matrix of integers. This is the very similar thing that we are using with vectors or anything like maps. If you remember, vector of int, you can create vector of strings, you can create a vector of doubles. Similar way, now we are creating a matrix of integers with 2 rows and 3 columns, and we are naming it as m. Now let's try running it again. So again here I forgot to have this matrix of t. Yeah. So now after we did this, there will be some like linker errors. Okay. Okay, I'm not going to explain this right now. When you are doing templates, you cannot have .h, and you can have, but it's more complicated. But the easiest way to code with templates is like just have all the things that you are having, the interface and the implementation in your CPP file. So here I'm just going to copy this entire thing, whatever I have here in my CPP file. Okay, in my .cpp file, I'm just copying this entire thing, and I'm just going to have it in my matrix.hpp itself. The matrix.hpp, we are having it at the end here. After we define the class, we are having the definition right here. And I am even going to delete this matrix.cpp file. Okay, deleted the matrix.cpp file. Now we have only one file called matrix.hpp, which have both the interface and the definitions of this matrix. I think I need a low stream. Okay. So with this, so yeah, our code just worked right now in main.cpp. Now you can easily go and instead of having an int, you can create a matrix of double instead. So I can just say I'm going to create a matrix of double, and it's named as n, and I'm going to have it like a 2 cross 2 matrix, and I can just say m of 0, 0, sorry, n of 0, 0, that's n of 0, 0 is equal to 1.23 or something like this, and then I can just say n dot print. So if you see here, the last matrix that was printed here is a double matrix. It can even store values of double here. This is such a powerful concept, and this is even one of the reasons why the standard C++ libraries, like there's one more name for the standard C++ library, which is called STL, which is called the standard template library. Okay, and these templates using these templates, we see here we just took like 2 to 3 minutes after the end of the class, but we just made our matrix class so generic that we can hereafter store any type of objects as matrices. Okay, and whatever we just did now, it will be more like the continuation of this would be your assignment 4. Okay, and the report is due by tonight. The interim report is due by tonight. Please send me the report, and I will see you next week. Thank you guys.